A few years ago, a jogger or a runner down the street or in the park, they would go running. They would only have a wristwatch on just to see how fast they were running. Now all the other devices are coming online as part of the Internet of Things. So you have automobile telematics, you have service warning lights, you have traffic signals, other functions. They're all coming on to the mobile network. And so the operator's challenges are to manage capacity requirements, as it always has been. But the Internet of Things is going to add a new feature to this where they've never seen this type of traffic before. It's by the Cisco Mobile VNI, which came out on February 4th, 2014. By the year 2018, there'll be more than 2 billion additional devices on. And we're not talking about smartphones and things like that. We're talking about these other devices. So that's new growth that they're not used to seeing before. Think of feature phones when they came out. They knew how to engineer the network for that because they could figure that out. When the smartphone came out, it was very difficult. The service provider bringing up the smartphone, they did not know how to engineer the network. They didn't know all the applications and the signaling storms that would come up. So that wreaked havoc on their network for a long time. So again, most operators were afraid of what might happen to their network with all these billions of devices coming on. So in the past, they were able to kind of engineer their network based upon maybe a marketing forecast or a sales forecast. Sometimes it was right, sometimes it was wrong. So you'll see the waste down here because they've over-engineered the network before the actual traffic came on. And then as time went on, the traffic started to spike. And when it spiked, then they were behind the curve on that. And it's always a catch-up. And as we all know, operators take anywhere from 5 months, 6 months to maybe a year or even 18 months to provision a network in time. Well, with 2 billion devices, that's a couple million devices per day coming on the network. You know, if you start out very, very slow, you're going to be way behind the curve very, very quickly. So as we tap through, the ideal is to be just ahead of the curve with the flexibility of dynamic shifting of the capacity. So capacity scaling is automatic within the network. The network, as we've always said, needs to be very, very intelligent. And that's what we're talking about in this case with the virtualized packet core. So in this case, we're going to use a machine-to-machine application with a partner of ours, which will allow us to go ahead and start to develop applications for machine-to-machine. So in this case, we already have a few of the machine-to-machine applications already loaded up into the tool. You'll see like city, light, and power. So the power and lights and things like that. Pay-as-you-drive insurance companies. So other applications. So the application that we created for Mobile World Congress is this car concierge service. So it's a new service offering. We have this onboard device, OBD it's called, that plugs in underneath the steering column, which is a diagnostic port on the most vehicles as of about 2000. So you can pull this information like what's going on with the automobile if you had a warning light come on. So in this case, we're going to pull that information, and this new car concierge service is going to aggregate this information and actually positioning it to sell it to other industries, like the way that you travel to work every day or home. So that routing information is important to the highway departments. Average speed. So if you drive too fast, then the insurance companies probably want to know because now you're not a safe driver. So if you're a good driver and you stay below the speed limit, maybe they give you a break on your insurance. So those are some quick analytics that you can pull out of the vehicle. So in this case, we're going to go to our portal, our machine-to-machine portal, and we're going to start to configure the car concierge service on our machine-to-machine portal. We develop how many SMS messages, other types of traffic profiles that are configured into the tool, and how much will be in there from a rate plan perspective. We'll also give this car concierge service a free 60-day trial. So that way there we're actually gathering information how they're going to impact my network, because I don't have unlimited resources to give them for 60 days, but I can give them kind of a controlled trial, so that way there I know what their traffic profile looks like. So we've now configured the machine-to-machine portal, exactly the configuration that we think they'll need. So here we are, we have our car concierge service now ready to ship these onboard devices to a larger audience in a particular part of the country. So with this, now we have to start to provision the network, the virtualized packet core, to start to figure out exactly what we need. So we use Prime Fulfillment to build our virtualized packet core. So in this case, we're going to look at the SAE gateway in the West Data Center, because that's where we have available virtual machines or virtual memory. We're going to put the SAE gateway in the West Data Center. So we see the image, the West Data Center, that's where we're going to spin up our virtual machines. We're going to deploy the service. We're going to fill out our little template and pull in the resources with Prime Fulfillment. We're just going to utilize a few KPIs. So in this case, we got Car Concierge. We have one instance that will be ready. 4 total SAE gateways or virtual machines for SAE gateways. We'll have 1 hot standby or 1 standby that's active. We'll have a threshold of 85% utilization on 1 gateway before the next one is automatically provisioned. And then we will decommission the backup SAE gateways as the traffic offloads. And we'll walk you through this use case of Car Concierge as they turn on the service. Oh, I'm sorry. First we spin up the actual configuration, and this is what we're going to do with OpenStack. So we just built our virtual machines. With Prime Fulfillment, we've gone out. We have to go over this way just a little bit. We've got our SAE gateway active. We have the one with the bars in queue. We have 2 backup ones that are there. And now the service has been deployed, and our SAE gateway number 1 has light loaded traffic. We have a few users that have adopted this service. As time goes on, the service starts to come up. The gateway gets a little bit more heavily loaded. And now this inclement weather comes in, an ice storm in Atlanta, Georgia, where they're not used to having ice or snow or anything else, or it could be Tokyo, where they had the biggest snowstorm in 50 some odd years. So with this, now all of a sudden people are looking for a new way to get home or to the office, so they're using their Car Concierge service to find alternate routes to their destination. This has now put a strain on SAE gateway number 1. It's over 85% utilization. If you remember the threshold, we set it for 85%. Once it hits that, spin up another instance. So that's where SAE gateway number 2 dynamically was spun up. And it's running about maybe 35% usage. Up in the top corner, you now see the packet core SAE gateway number 2 is being active. It's light blue. And the backup one, one of the non-booted ones has now been booted up and is in the backup position. So if traffic keeps on going, that will become active. The good thing about Cisco versus some of our competition is this is the same platform, our Quantum Virtualized Packet Core. We leverage our Star OS, which we purchased from Star Systems. With Star OS has been deployed in over 300 networks, operated networks across the globe in more than 75 countries. The same software that runs on our purpose-built platforms, the ASR 5000s and 5500s, it's the same software, same revision, everything on the virtualized platform. Our virtualized platform will run on a Cisco UCS or another x86 processor based server. So again, we have a single modular OS that can go virtual or purpose-built. And again, the purpose-built hardware is not going away. It's there. It's a mainstay for a lot of carriers across the globe. But for niche applications or newer applications like machine-to-machine or Internet of Things, with that dynamic flexibility that's needed to carry that traffic because it's uncertain what it will be, this is a perfect platform for that types of service. We've had this service tested by the European Networking Testing Center, and they've written a white paper validating that what works on our virtual packet core works on the same purpose-built hardware, so it's the exact same system. Lots of operators, like I said earlier, have deployed this, so their networking group and their IT group will understand the exact same configurations. How this fits, so we take a look at bringing the virtualized packet core into the virtual networking functions. It can be configured so that it's focused on maybe a small cell network with a virtual function. So that way there are more interrupt type capabilities with small cells. The storage piece, that's more from machine-machine IoT, and there are other instances that may need more computing power. So it can be automatically done, or they can bring up, say, a GGSN, a P gateway, an S gateway, or it can automatically be configured, as we showed in the demonstration, automatically once it goes over certain parameters. This is how everything fits into the Cisco Open Network, or the One. And what we walked you through today, somewhat quickly, but we walked you through the virtualized packet core with a use case of being machine-to-machine or IoT, Internet of Things. Great other applications are something like a network as a service, MVNO, premium mobile broadband or LTE services that can target specific vertical industries or smaller markets, smaller operator markets that the Cisco hardware or physical platform had not been able to get into because of the price points. But all those operators wanted this platform. They're actually able to get it now in a much smaller form factor, and with the virtualized functions, they have better capabilities.